So, let us look at some examples now for energy transfers. So, linear triad. So, imagine that we have K prime, P and Q. Triangle, we can form a triangle like this. Now, what about energy going to K prime from P with Q as a helper? Now, UU maybe I may not write it. So, what is it? This straightforward answer, imaginary K prime dot UQ, UP dot UK prime. So, K prime is in that direction. What is the direction of UQ? Must be perpendicular to Q. It is in a plane, but it is perpendicular to Q, it is also perpendicular to K prime, because K prime P Q are in the same line. So, what happens to this term? 0. So, energy transfers in a collinear triad is 0. So, this is nice result. In fact, it is a meaningful result. This is another way to say that this formula is a good formula without delta, because I mean if you do this fluid mechanics, you say that if the waves are if the triad is along same line, you should get 0. So, it comes from here. Now, let us do the example which we have been working on for quite a while. Now, this example you have seen it again and again. So, third time we are seeing it. So, how many modes are there? So, cos y, cos x and this one. So, we have this, I mean I did this before, so I do not repeat it. So, there are two triads, I mean K and minus K triad, and one triad I have drawn it here. So, 1 0, 1 1 and 0 1. So, here it is K equal to P plus Q, K equal to P plus Q. Now, Q, P and K in that direction. And what is the magnitude of this Fourier modes, or not magnitude, the Fourier amplitudes? So, 0 1 is B, 0 1 is here, Ux is B. So, B. So, the red lines are showing the vectors. 1 0 is C along y direction. So, I am assuming B, I mean right now C is positive, okay. I mean negative means arrow will go in the opposite direction. And 1 1 has both the components 1 I and A by I and minus A by I, it comes from here. So, it is in that direction, root 2 A by I, right, because it is just magnitude is root 2 A and that direction will come from here, A by I, and it is a complex vector. So, it is really a schematic, okay. I mean I can't really draw as a real vector in this, but like that. So, we can compute now SKPQ. So, let us compute it. So, we use our formula, the second formula. So, S U U K prime P Q. So, it is going to be imaginary minus, so not K prime, K. So, this is a plus sign. So, if you say minus K prime, there is minus sign. K dot UQ UP dot U star of K. So, K prime, K is 1 1. So, I am calling this 1 1, K 1 1. So, 1 1 dot UQ, UQ is along y direction. So, K is 1 comma 1 is a 2D vector dot 0 comma C, right. So, that gives you C. I will put imaginary part here. So, that is in fact it is just C, right. What about dot product of this? UP is, this is P, 0 1 is, 0 1 is, I am calling it no, what did I make a mistake? This is Q. So, this P, this P. So, this is vector P. So, 0 1 is B x hat, UP is this thing, and what about U star K will be minus root 2 A by I, and direction is in that direction, okay. So, x hat minus y hat by root 2. you will see if you do Cray Herring it is easier, that is why Cray Herring, but now the first guys will, so x hat is 1, x hat y hat is minus 0. So, this gives you imaginary C B, so B, the B by I is here root 2. So, there is a minus sign, there is a minus sign here, there is a minus sign here, because I do complex conjugate, no. So, there is a minus sign, so this becomes minus I like that. So, minus 1 by I is I. So, I here, and root 2 will be root 2 will cancel. So, root 2 is gone and A will come here. So, this is ABC. Okay. Similarly, you can do for other things. So, let us do one more thing, P to Q, Q to P with K prime, K is a K prime. So, K prime is minus, okay, mediator. So, this imaginary, well, so I am going to use now my, I want to use this formula. So, P dot U K prime minus sign, U P dot U Q. What is this? U P dot U Q, what is U P dot U Q? This one. 0, because they are perpendicular, U P and U Q are perpendicular. So, this 0. So, in fact, you can also compute the other guy. So, I can just draw this picture, what happens. So, if you draw this 1 1, 1 1 is giving, so there is no energy, so this is 1 0, sorry 0 1, this is 1 0 and this is 1 1. So, there is no energy transfer from 0 1 to 1 1 is 0, but there is energy transfer from this one to 1 1 like that. So, the energy transfer from here to here and this energy transfer from here to there. This I did not compute, but you can compute them. 1 1 is getting minus A. So, okay. So, in fact, it is the other way around. So, this ABC I just showed you, P is 0, so ABC, and this is also ABC. So, whatever comes goes 0 1 to 1 1 to 1 0, and ABC, if you recall, A is, well, this was solved, I solved this, A is constant and BC change sign. So, B is oscillating, okay. So, this is there in our solution. So, B and C will change, so then it goes in opposite direction. So, ABC also changes. So, this is an example where our transfer is changing in number, but I use the same formula. So, if you look at the one of the pictures which I have in my in the book, this energy transfer ABC is also oscillating. So, it and in fact, this is same as what similar, okay, is not, this is not what is for ASQ asymmetric square pattern, but the equations are not the same, but basically the dynamics is the same. Energy goes from one mode to other mode and then it back. So, it oscillating, okay. So, it is connected with that, and that is why I am interested in pattern for which is blinking pattern, and this is capturing that, okay. So, is that clear? So, this is how we compute. Now, slightly more complicated problem is the 3D problem. So, this one, right, this also we have done in the class, but energy transfer we need to compute. So, 1 1 2 0 1 1, so they form a triad, and you can compute, given this we can compute. So, there may be more triads which I will do in the next class, but does not matter, if you are triad you can compute energy transfer among that triad. So, this is the triad above 1 1 2, and it turns out I can only tell you the, so I will draw the picture here, okay. So, this number you can, I will ask you to do as a, not homework because this is exercise only, but just do at home, 1 0 1 0 1 1 1 1 2, okay. So, they will add up to 0. So, this k prime I should minus 1 minus 1 minus 2. So, this k prime p well I do not know what. So, it turns out that you get like that minus 2 ABC and this is minus 2 ABC, and there is no transfer from here to there, 0. So, ABC will again change sign and it goes back and forth. Okay. So, this is interesting observation for understanding patterns. So, if this mode is blinking, then I know why it is blinking and who is supplying energy. So, in fact, it is interesting that 0 1 1 and 1 0 1 do not exchange among themselves, and we need the third mode to facilitate this dynamics. Okay. So, one can make use of this energy transfers to understand how the patterns are evolving in time, or how they are exchanging energy, who is giving energy, who is taking energy. Okay. So, this is where I will stop. Thank you.